Afternoon. This is the last video of our Unit 8 notes. So this notes page is on Tables and Graphs Part 2. So we're going to extend what we did Part 1 onto Part 2, and now what we're going to include in this is we're also going to talk about the independent versus the dependent variable about the word problem. We're going to talk about unit rate, the equation given, fill in our table, and then graph. So let's get started. The first word problem says, John opens a bank account with Wells Fargo. At the end of each week, he adds $10 to his account. So the independent variable would be the number of weeks that he is adding money. And the dependent would be his total amount. The unit rate is $10 per 1 week. So that means that your unit rate is what is per one item. So if it's weeks, $10 per week. If it's pizzas per person eaten, then it's two pieces of pizza per person. So it's what you're trying to find for 1 unit. So this is our unit rate is $10 for every week. So our equation is going to read like this: y is equal to, we're doing $10 every week. So our week is our x value and our total is our y value. So right here in our table, this is where our weeks are. So this is going to be weeks, and that's our x value, and this is going to be our total, which is our y value. So if we have saved money for 0 weeks, we're going to have $0. But if we save for 1 week, we'll have 10. If we save for 2 weeks, we'll have 20. If we save for 3 weeks, we'll have 30. If we save for 4 weeks, we'll have 40. If we save for 5 weeks, we'll have $50. So now we can graph the Wells Fargo account by putting it on the x and y axis. So we're going to look at our x values. We go up to 5. So down here, we could probably skip every other one and count by ones because we have enough space. And on our y-axis, we go all the way up to 50. So we probably need to count by 5s, and I'm just going to label my 10s. So again, we try to make our axes fit the data that we have. So if I have $0, if I save for 0 weeks and I have $0, that's going to go here. 110, so over 1 up 10. 220, so over 2 up 20. And I'm getting these ordered pairs right here. So this was 1, 10, 2, 20, 3, 30. So over 3, so that's my 3 weeks. 3 weeks gives me $30. 4 weeks gives me $40. 5 weeks gives me $50. And if you want to label this so that you know that this is your weeks, because that's your x-axis, and this is your total, we can label that as well. And that's your y-axis. So each of these points represents a week. So week 1, $10, week 2, $20, week 3, $30, week 4, $40, week 5, $50. And those all match up. And then we can connect them to make it a nice linear function. Now, actually, you know what? We probably should not have connected this because you don't put money in between the days or in between the weeks. We just deposit once, deposit once. So actually, if you have a pencil, erase that line. Mine's a pen, so I'm just going to kind of leave it there. My whiteout is gone. But actually, we did not need to connect that line for this one. All right, so let's recap what we just did. We read our word problem. We decided which one was the independent, which one was the dependent. Your weeks changes your total. We found the unit rate because it's $10 for every 1 week. Your equation was y equals 10x. And then we filled in our table and then we graphed it. Let's go down here and answer some questions. So a year is 52 weeks long. How much money will John have in his account after depositing money for 1 entire year? So y is our total, $10 for every week, and we do 52 weeks, so that's why we're able to put 52 in for x. And 10 times 52 gives us $520. So John will have $520 at the end of 1 year. All right, John is saving up for a new iPad Air that costs $500. How long will it take him to save up that much money? So now we have our total, which is our y. We don't know how many weeks that is, but it's $10 for every week. So that's why we're going to leave that variable there. Well, we know how to solve a one-step equation. So divide by 10, and it's going to take him 50 weeks. So 50 weeks is how long it will take John to be able to save up that much money to buy the iPad Air. All right. Now we're going to move down to number 2, and we're going to talk about Jake. So Jake volunteers at a car wash to help raise money for his school. They are charging $5 a car. How many cars did they wash if they raised $335? So your independent variable is going to be the number of cars washed. Your dependent variable is the money that they earn, so your total money earned. Because how many cars you wash changes your total. The unit rate, well, it's $5 for every 1 car, so that gives you your unit rate, so $5 per car. So the equation is going to say y is equal to, well, we're charging $5 per car washed. All right. Now we're going to fill in our table. So the number of cars goes here. That's our x. And then the total amount of money goes here. That's our y. If we do 0 cars, we raise $0. If we do 1 car, we raise $5. 2 cars is $10. 3 cars is $15. 4 is $20. 5 is $25. And then we can go and graph it on the x-axis and the y-axis. So we're going to look at our x values. We go up to 5. So we know that we can kind of graph a little more spread out. And then on our y-axis, 0 to 25. So we need to go up to 25. So I'm going to count by 5s. So 5, 10, 15, 20, 25. And then I'm just going to graph. 0, 0 goes here. 1, 5, so over 1, up 5 goes here. 2, 10, 2, 10 goes here. So for 2 cars, $10. For 3 cars is 15, so 3 cars, 15. 4 cars, 20. 5 cars, 25. And we can label the axes. So that's number of cars. And this was our total. And then we're not going to connect it because we don't wash part of a car and get part of money. So we're not going to connect it. So this is a nice discrete graph. And I'll tell you that word. And you'll hear that in 7th grade. You'll hear it in 8th grade. But discrete graph means we don't connect the points because we're not going in between cars. How many cars did they wash? Did they raise $335? So if our total is $335, and we know that it's $5 per car, we set up the equation 335 equals 5x, and then divide by 5. And 335 divided by 5 gives us 67 cars. So Jake helped his school wash 67 cars. Okay, so that's how you do number 1 and 2 on the front. Now we've got one more to do together, and then I'm going to let you pause the video so that you can do the last 3 on your own. Green Hope High School Spring Carnival charges $1.50 per ride. So the independent variable will be the number of rides that you ride. Your dependent variable is going to be the amount that you spend. Because the more amount you spend. Because the more rides you ride, the more money you spend. So this is going to change the amount that you spend. Your unit rate is $1.50 a ride. So your equation would be y is equal to 1.50 x, where x is our number of rides. So number rides, that's your x value. And this is your total cost. All right, so if we do 0 rides, it's going to cost us $0. If we do, let's do 2 rides just to make a nice whole number. 2 rides is $3. 4 rides is going to be $6. 6 rides is going to be $9. 8 rides is going to be $12. Notice I'm just adding 2, adding 3. sorry. And then $10 is going to be 15. All right, so, and the reason why I did that is because I don't want to have to graph decimals. So I just doubled the rides, and then that gave me 3, because 2 times $1.50 is 3. And then I just saw my pattern. Now I'm going to graph it on my coordinate plane. So 0 to 10 here. So I can't just do, I can't spread this out. So I'm going to do 2, 4, 6, 8, 10. I'm not going to count by ones, I'm going to count by twos. And then here I'm going to count by twos as well. Well, let's see, 15. Maybe I'll count by threes. 3, 6, 9, 12, 15. That'll work. 3, 6, 9, 12, 15. So this is the number of rides. And this is the total cost. So for 2 rides, it cost me $3. For 4 rides, it cost me $6. For 6 rides, it costs me $9. For 8 rides, it costs me $12. And then for 10 rides, it's going to cost me $15. And again, we're not going to connect these. This is a discrete graph because you're not going to pay for part of a ride. You either do 1 ride or 2 rides or 3 rides, but you don't go in between. So we're not going to connect those lines. So now using this situation, we're going to answer the following questions. If Michael rode 15 rides, how much money did he spend? So our equation is y equals 1.50x, where x is our rides. He rode 15, so that's going to go here for x. So y is equal to $1.50 times 15, and $1.50 times 15 is $22.50. So Michael's going to spend $22.50 if he rides 15 rides. If Tara and Hope had a combined $75 to spend on rides, how much could each girl ride? So let's figure out how many rides they could get total. So 75 is the number of rides, and it's $1.50 a ride. We're going to divide by $1.50. So 75 divided by $1.50. So there's 50 rides total. Now each girl, they're going to split that in half. So that's 50 rides. So 50 rides total. So the question said how much does each girl ride? So 50 divided by 2 gives me 25 rides per person. So each girl gets 25. So each girl, oh, that's not how you spell gets. That's just. Each girl gets 25 rides. Okay. All right. So go ahead and pause your video, and I'm going to show you the answers for the rest of the problems, numbers 4, 5, and 6. And then here you go. So number 4, the hours worked versus the total money take home. Your unit rate is $12 an hour. Your equation is 12x equals y, or y equals 12x. Both ways work. Your table is right here, 112, 224, 336. I'm going to count these 1, 2, 3, 4, 5, 6. I'm going to count by 12s just because 12, 24, 36, 48, 60, 72, and then I'm just going to mark them off. Okay, and right here, how much will Rachel, and you can work part of an hour, so we're actually going to go ahead and connect these because she can get in between hours. Like she can work 4.2 hours or 6.25 hours. So that's why I am going to connect those. The questions down here said how much will she make from her first week if she worked 40 and a half hours, $486. What if she earned $42 more the second week? How many hours did she work that week? She only worked 3.5 hours extra. So that's number 4 for Rachel. Number 5, we're talking about the fun run at West Cary, which is happening in April. So if you are interested, make sure that you go online and sign up. So right here, the independent variable is the number of students. The dependent variable is the number of people signed up. So the more students you have, the more people will sign up, because if each student has 5 per person, sign up for them, then that gives us our unit rate. Our equation is y equals 5x. Here's the table I came up with. If you had 0, 0 on there, that works. I just forgot to put it on my table. And then here's my graph, and I connected my points. I don't know if we should have connected these points because you can't have part of a student. So actually, this one should not be connected. All right, to answer some questions down here, if there were 345 sixth graders at West Cary, how many people signed up for the race just from sixth graders? Well, 5 times 345 gives me 1,725 people will be at the fun run, which is what we want. We want everyone to sign up. So please make sure that your friends are signing up for the fun run. It is an awesome time. We have a great time. There's lots of music and dancing and prizes, and you get to throw chalk on your teachers. It's a lot of fun. So you guys should all come. And then part B says, if a total of 1,110 people signed up, then how many students participated in getting people to sign up? Well, we divide this by 5, and that gives us 222 people participated by getting them to sign up, because it was 5 people per student signing up. And then number 6 is about Boy Scouts selling popcorn. Sam sells 3 boxes for 24 bucks. So the number of boxes sold is your independent. Your money raised is your dependent, because this money depends on how many boxes you sell. The unit rate would be 24 divided by 3, which is 8. So our unit rate is $8 a box. Okay, because remember, you're trying to find it per one item. Your equation would be y equals 8x. And then here's my function table right here with my ordered pairs. I then graph them here. Then I answered some questions. If Sam raised $128, how many boxes of popcorn did he sell? 16. And then what if his brother sold 12 boxes? How much money did he raise? He raised $96 by selling 12 boxes. If you have any comments on this video, again, this is one of the longer videos that we've had, but it's very in-depth. There's a lot to it. Please just put your comment or your question at the bottom, and I can hopefully answer it as soon as possible, if not tomorrow in class. All right, have a great afternoon, and I will see you guys tomorrow.